To have a 9-foot healthy female shark eaten alive straight up set this scene of, it's a murder mystery.
It all began in 2003, off the remote coast of southwestern Australia, where a team of marine scientists was carrying out one of the largest great white shark tracking projects ever attempted. Their goal was simple: attach tracking tags to healthy sharks and discover where these legendary predators disappeared when they left the coastline behind. On that day, after hours of waiting, a massive female great white finally surfaced beside the research boat. She measured nearly 9 feet long and weighed around 500 pounds. Calm, powerful, and completely fearless, she moved through the water with the quiet confidence of an animal that had ruled the ocean for millions of years. Watching her glide beneath the surface, one member of the crew gave her a name, Alpha. The name fits perfectly. Alpha was no juvenile. She was a fully grown apex predator, the kind of hunter that sits at the very top of the marine food chain. Nothing in the ocean was supposed to hunt her. Nothing was supposed to make a great white shark afraid. Before we go any further, please subscribe to our channel and help us reach our goal of 1,000 subscribers. Before releasing her, the scientists carefully attached a small electronic data logger to her body. It looked ordinary, but it would quietly record everything Alpha experienced. Every second it logged her depth, the surrounding water temperature, light levels, and movement. Unlike a GPS tracker, it sent no signals. It simply stored every detail in silence. Months later, on a preset date, the tag was designed to detach automatically, float to the surface, and send all of its recorded data to a satellite. If everything went according to plan, the researchers would receive a complete record of Alpha's journey through the open ocean. But there was one detail nobody paid much attention to at the time. Once Alpha disappeared into the deep, no one would ever see her again. No cameras followed her. No divers watched her. No boats stayed nearby. Whatever happened beyond that moment would happen in complete darkness, hundreds of miles from anyone who could witness it. The only witness would be the tiny tag attached to her body. 4 months passed. Then something unexpected happened. Instead of transmitting its data from the middle of the ocean as planned, the tag suddenly washed ashore on a beach only a few miles from where it had first been attached. The shark never returned. Someone recovered the tag and delivered it back to the research team. Soon the stored data appeared on a computer screen. Everyone expected to see an ordinary migration. Gentle movements through familiar waters, slow changes in depth, nothing unusual. Instead, the tag revealed something that made the room fall completely silent. Within minutes, it recorded Alpha plunging nearly 1,900 feet straight into the darkness below. Not a gradual dive, not normal hunting behavior, a sudden, violent descent. Then came the second reading. At that depth, the surrounding ocean should have been freezing, around 46 degrees Fahrenheit. Instead, the sensor suddenly recorded a stable temperature of 78 degrees. For a few moments, nobody spoke. 2 numbers. That was all it took. A depth of nearly 1,900 feet, and a temperature that simply should not have existed there. Riggs stared at the screen again and again, hoping there was another explanation. There wasn't. Those 2 readings quietly transformed an ordinary shark tracking project into one of the greatest mysteries marine science had ever encountered. Before you can understand why those numbers terrified the researchers, though, you first have to understand what Alpha really was. Most people know great white sharks are dangerous. Very few truly understand what that means. A great white is not just another large fish. It is one of evolution's greatest predators. For millions of years, it has occupied the very top of the ocean's food chain. Nothing hunts an adult great white. That is exactly what being an apex predator means. Everything beneath it lives in fear of it. Above it, there is supposed to be nothing. Which is exactly why what happened to Alpha should have been impossible. To understand why those two numbers shocked everyone in that room, you first have to understand the animal wearing that tag. A great white shark is not simply a large fish with sharp teeth. It is the result of millions of years of evolution, refined again and again into one of the most efficient predators nature has ever created. The largest individuals can grow beyond 20 feet in length and weigh well over 5,000 pounds. Their senses are extraordinary. A single drop of blood diluted through an enormous volume of water is enough for them to detect. They can even sense the tiny electrical signals produced by a heartbeat hidden beneath the sand, using specialized organs in their snouts, unlike anything humans possess. When they attack, it happens with breathtaking speed. In just a few seconds, they can close the distance before their prey even realizes danger is approaching. Even their teeth seem designed to defeat time itself. Rows of razor-sharp, serrated teeth constantly replace one another, so whenever one breaks, another immediately slides forward into place. It is a weapon that continually rebuilds itself throughout a lifetime that can stretch beyond 50 years. And the oldest great whites are something even more remarkable. They are not simply larger sharks. They are decades of experience, instinct, and survival, wrapped inside thousands of pounds of muscle. Some were already hunting these waters long before scientists ever arrived to study them. But none of that is the most important part. The real story is where they stand in the food chain. A great white is an apex predator. By definition, that means nothing hunts it. Every creature below it has evolved to avoid becoming its next meal. Above it, there is supposed to be nothing. That is what apex means, the top, the ceiling, the final predator. For decades, marine biologists accepted that as fact. Yes, orcas had occasionally been seen attacking great whites. Large sharks sometimes fought over food. But an animal that deliberately hunted a healthy adult great white, killed it, and swallowed it as prey? That simply did not exist in the scientific model, which is why nobody wanted to say out loud what Alpha's tag was beginning to reveal. The first clue was the depth, nearly 1,900 feet. Long before the temperature reading appeared, that single number already raised serious questions. Great white sharks are not deep-sea hunters. Most of their lives are spent in the brighter waters closer to the surface, where seals, sea lions, and other prey are abundant. The vast majority of their time is spent within the first 1,000 feet of the ocean. That is their world. So when Alpha's tag showed an almost vertical plunge to nearly 1,900 feet in only a few minutes, the possibilities became alarmingly limited. She was almost certainly not diving there willingly. Something was taking her down, something powerful enough to overpower a fully grown great white, something capable of reaching those crushing depths with almost effortless speed. Now, imagine what that place is actually like. At 1,900 feet below the surface, sunlight has completely disappeared. The water is near freezing. The pressure is immense. It is a world of darkness so complete that almost nothing from the surface ever reaches it. This is not somewhere a coastal predator casually travels. Yet something dragged Alpha into that darkness, leaving behind no struggle, no witnesses, and no evidence except the tiny recorder still attached to her body. And that raises an even more disturbing question. What kind of animal would be capable of pulling a 500-pound apex predator that deep, that quickly? It would have to be stronger than a great white, faster than a great white, and perfectly adapted to a part of the ocean where great whites almost never go, Nothing scientists knew checked every one of those boxes. Before we reveal the second clue, make sure you're subscribed to Reef Discovery, because this is the exact moment where a fascinating mystery becomes something much stranger. The second clue was the temperature. At nearly 1,900 feet below the surface off Australia's coast, the water should have been around 46 degrees Fahrenheit. That is completely normal. And if Alpha had simply died, or if the tag had fallen off and drifted into the depths by itself, that is exactly the temperature it should have continued recording. Cold water, getting colder as it descended. Instead, the impossible happened. The temperature suddenly began rising, not by a few degrees, by more than 30, from roughly 46 degrees to a steady 78 degrees Fahrenheit. And it stayed there, not for a second, not as a random sensor error. It remained stable, a constant 78 degrees, nearly 1,900 feet beneath the ocean surface. There was only one explanation that fit the evidence. The tag was no longer in the ocean. It was inside something alive, something warm, something that had swallowed Alpha whole, tag and all, before carrying its meal deep into the darkness. Imagine realizing that for the first time. Somewhere beneath the surface, an unknown predator had eaten a 500-pound great white shark, descended almost 2,000 feet into the abyss, and disappeared without leaving behind a single visible trace. No splash, no blood, no photographs, no witnesses. The only reason anyone ever discovered what had happened was because one small piece of plastic eventually washed ashore 4 months later, carrying the entire story inside its memory. Riggs went over the data again and again. He searched for another explanation, but every time the evidence pointed to the same conclusion. Alpha had been eaten. Now there was only one question left. What could possibly have done it? The researchers began working through every predator the ocean could offer. One by one, they started eliminating the suspects. The search for Alpha's killer had officially begun. The researchers gathered every possible suspect the ocean could offer. One by one, they examined every predator powerful enough to overwhelm a fully grown great white shark. And one by one, every theory collapsed. The first suspect was the orca. At first glance, it seemed like the perfect answer. After all, we already know killer whales hunt great white sharks. Off the coast of South Africa, researchers have repeatedly documented orcas attacking them with astonishing precision. They flip the shark upside down, forcing it into a trance-like state known as tonic immobility. Once the shark is helpless, the orcas slice open its body, remove the nutrient-rich liver, and often leave the rest behind. It is one of the most efficient hunting techniques ever observed in the ocean. For a moment, the evidence almost seemed to fit. A recently swallowed shark, mixed with cold seawater, could potentially explain the mysterious 78-degree temperature recorded inside Alpha's tag. But then the researchers looked at the second piece of evidence, the depth. That single number eliminated the orca almost immediately. Killer whales simply do not hunt nearly 1,900 feet below the surface. They spend most of their lives in the upper layers of the ocean, and even their deepest recorded dives fall far short of where Alpha's tag ended up. An orca could kill a great white, but it could not explain where the tag went afterward. The behavior did not match the evidence. So the scientists crossed the orca off the list. Their next suspect seemed even more promising. The sperm whale. Unlike orcas, sperm whales are true deep-sea hunters. They regularly dive thousands of feet beneath the surface in search of giant squid. Some of the largest males grow beyond 60 feet long and weigh over 100,000 pounds. Swallowing a 9-foot shark would hardly challenge an animal that size. This time, the depth made perfect sense. But another problem appeared. Temperature. A sperm whale's body stays close to 97 degrees Fahrenheit. If Alpha's tag had been inside one, the recorder should have shown something much warmer than 78 degrees. And there was another issue. Sperm whales are specialized hunters of soft-bodied squid, not muscular surface predators like great white sharks. Once again, the evidence refused to fit. Wrong temperature, wrong diet. Another suspect eliminated. Slowly, a disturbing pattern began to emerge. Every animal capable of reaching those incredible depths had a body temperature that was far too warm. Every predator with a body temperature close to 78 degrees could not dive anywhere near deep enough. It was as though the evidence itself had drawn an invisible outline around the killer. And almost nothing in the known ocean matched that outline. That realization was perhaps the most unsettling part of the entire investigation. The researchers were not struggling because they lacked suspects. They were struggling because the predator described by the evidence was something marine biology barely believed existed. Every familiar explanation had failed. Every comfortable answer had disappeared. Whatever remained was going to challenge everything they thought they knew. Still, they kept searching. Could another large shark be responsible? Perhaps a giant tiger shark. Maybe an oceanic white-tip. Both are aggressive predators, willing to attack almost anything they can overpower. But neither grows large enough. Even the biggest tiger sharks ever recorded reach only around 14 feet. And swallowing a 9-foot great white whale requires far more than being slightly larger than the prey. It requires an enormous size advantage. Again, the numbers simply refused to work. Someone even suggested an enormous, colossal squid. The idea sounded dramatic enough. A creature with giant tentacles capable of wrapping around a shark and dragging it into the darkness. But that theory collapsed almost immediately. A squid is cold-blooded. Its body temperature matches the surrounding water. It has no warm internal cavity capable of producing the steady 78-degree reading recorded by the tag. One possibility after another disappeared. The orca, wrong depth. The sperm whale, wrong temperature. Large sharks, too small. Colossal squid, cold-blooded. Eventually, there was only one explanation left. And strangely enough, it had been swimming in front of them the entire time. What if Alpha had been eaten by another great white shark? Not one that was only slightly larger, not two rivals fighting over territory, but a great white so enormous that a fully grown 9-foot shark was nothing more than a single meal. The researchers did not arrive at that conclusion because they wanted to. They arrived there because the evidence left them nowhere else to go. Once again, the temperature became the key. Most sharks are cold-blooded. Their internal body temperature rises and falls with the surrounding water. Great white sharks are different. They belong to the mackerel shark family, a rare group of sharks capable of maintaining parts of their bodies significantly warmer than the surrounding ocean. Using an extraordinary network of blood vessels, they recycle the heat produced by their powerful swimming muscles. That heat keeps their muscles, brain, eyes, and digestive system much warmer than the freezing water around them. It is one of the adaptations that makes great whites such formidable hunters. Now, the puzzle finally began to make sense. A normal great white might maintain a stomach temperature somewhere between 65 and 70 degrees, but a truly enormous individual changes the equation completely. More muscle creates more heat. More body mass traps that heat far more efficiently. Inside the stomach of an exceptionally large great white, a stable temperature of 78 degrees suddenly became not only possible, but expected. For the first time since Alpha disappeared, every piece of evidence fit together. The mysterious temperature, the incredible depth, the behavior, everything pointed toward one astonishing conclusion. The predator was not an unknown sea monster. It was another great white, just far larger than anyone had seriously considered. There was only one mystery left. How large would that shark have to be? Marine researchers use a simple rule when estimating predators capable of swallowing prey whole. A predator is often about twice the length of its victim. Apply that rule to alpha, and the numbers become astonishing. The shark responsible would likely have measured around 16 feet long and weighed well over 2 tons. A giant sitting at the very edge of what science believes great whites can become. Perhaps even larger. For just a moment, imagine how the attack unfolded. A massive shadow rising silently from beneath. An explosive upward strike. The same ambush technique great whites themselves use against seals. Only this time, the hunter was hunting another apex predator. Alpha never stood a chance. The tag never recorded the attack itself. It only recorded what came afterward. The rapid descent into darkness. The impossible warmth. Yet somehow, those 2 measurements alone reconstructed an event that no human being had ever witnessed. And then another question surfaced. If one shark this large existed, could there be more? For over a century, fishermen, sailors, and researchers had occasionally reported seeing great white sharks longer than 20 feet. Most of those stories had quietly been dismissed as exaggerations or misjudged estimates. But what if some of them were true? What if the oldest and largest females spend almost their entire lives far from shore, roaming the open ocean where research vessels rarely venture? If that were the case, it suddenly became much easier to understand why science had never documented them. A shark could spend 50 years crossing thousands of miles of open water without ever passing close enough for humans to see. Perhaps we had not failed because these giants were hiding. Perhaps we had simply never been looking in the right place. That idea gained even more support when the researchers compared Alpha's recorder with tracking data collected from other exceptionally large great white sharks. Something remarkable happened. The body temperatures matched. The diving depths matched. Their migration patterns matched. One by one, every comparison pointed toward the same conclusion. The evidence was becoming harder and harder to ignore. Every comparison led the researchers toward the same astonishing conclusion. The evidence consistently pointed to one kind of animal. An enormous female great white shark. One so large that no scientist had ever officially documented her existence. And perhaps that was the most unsettling discovery of all, because it suggested that the biggest gap in our knowledge was not random. It was shaped almost perfectly around the very animals most capable of escaping our attention. The larger they became, the rarer they became. The farther they lived from shore, the less likely we were ever going to find them. In other words, the most extraordinary great white sharks in the entire ocean may be exactly the ones our research has been least capable of studying. Somewhere out there, this giant female had likely been roaming those waters for decades, doing exactly what apex predators do. Then, on one ordinary morning in 2003, she encountered Alpha, a fully grown 9-foot great white shark, and treated her as nothing more than another meal. Moments later, she disappeared into nearly 1,900 feet of darkness, finishing the meal where no human eyes could ever follow. It is an unsettling image. And the deeper the researchers looked, the stranger the story became. Once they accepted that Alpha had likely been eaten by another great white, they returned to decades of scientific records searching for anything they might have overlooked. What they found changed the picture completely. Great white sharks eating other great white sharks was not an isolated mystery. It had been quietly hiding in the evidence all along. Researchers had already documented larger individuals dominating smaller sharks around feeding sites. Young great whites were known to disappear in areas occupied by much larger adults. The behavior even begins before birth. Inside the womb, developing shark embryos sometimes consume their own unhatched siblings, a phenomenon so common that it has its own scientific name. Then there were the bodies. Several dead great whites had washed ashore carrying enormous bite marks. The spacing of the teeth, the shape of the wounds, the distinctive serrated cuts, everything pointed toward attacks by another great white shark. Even more remarkable, divers had photographed living great whites carrying massive healed scars with exactly the same unmistakable pattern. These were sharks that had survived encounters with members of their own species. Then came another clue. Researchers tracking a pregnant porbeagle shark, a close relative of the great white, recorded evidence suggesting it had been attacked and likely eaten by a much larger predator. Among all the possible suspects, the great white shark ranked near the top of the list. None of these discoveries proved Alpha's story by themselves. Each one could be explained away. Perhaps it was a territorial fight, perhaps competition over food, perhaps an isolated act of aggression. Scientists are careful for a reason. Single observations rarely tell the whole story. But when every piece of evidence is placed side by side, when decades of observations are combined with the extraordinary data from Alpha's tag, a different picture begins to emerge. The largest great white sharks do not simply compete with smaller members of their own species. Sometimes they eat them. And that realization changes far more than one mysterious shark attack. For generations, we have thought of the great white as the unquestioned ruler of the ocean, the final predator, the ceiling of the marine food chain. But if the largest great whites sometimes become predators of smaller great whites, then perhaps that ceiling never really existed at all. Perhaps the true apex depends entirely on size. And the truth is, we simply have not explored enough of the ocean to know. The Pacific Ocean alone covers nearly 60 million square miles. All of Earth's oceans together stretch across more than 100 million square miles. Yet humanity has explored only a tiny fraction of that vast wilderness. Even our shark research has limitations. Most tagged great whites are younger animals that regularly approach the coastline. The oldest and largest females spend much of their lives far offshore, in places where research vessels rarely go. Trying to understand the entire species using only those coastal sharks is a bit like trying to understand elephants by studying only the calves near the edge of the herd. It leaves enormous gaps in our understanding. Those gaps affect more than simple population estimates. Current conservation models account for fishing pressure, habitat loss, and illegal finning. But they rarely consider the possibility that great whites themselves may be an important source of mortality for smaller members of their own species. If that assumption is wrong, then many of our estimates may also need to change. And the consequences extend throughout the entire marine ecosystem. We already know that the presence of great white sharks changes the behavior of seals, sea lions, fish, and countless other marine animals. If giant great whites are quietly controlling populations from within their own species, then those effects ripple through the food chain in ways we may not yet understand. Remove one assumption from an ecosystem, and everything built upon it begins to shift. Perhaps the most remarkable part of this story is that we still do not know the identity of the predator. Alpha received a name. The shark that killed her never did. No photographs, no tracking tag, no official record. she carried out one of the most extraordinary acts ever inferred by marine science, then disappeared back into the darkness without leaving another trace. As far as anyone knows, she is still out there. If you want to imagine what such a shark might look like, there is one famous example worth considering. Deep Blue. She is the largest great white shark ever reliably filmed.